is stored in the form of keys and values, where key is a unique key which refer to a value. The value is actually opaque to the database, which means it does not care what type of data you store as a value. It could be a character, it could be an integer, it could be an object, it could be anything, right. So, however, though this is a very simple data model, it is very good for partitioning the data, it works very well. But there are few drawbacks as well, like you can't do data level querying and indexing, because they only all queries has to be run through the keys, right. And we can't store any data structures or relations with any key value stored databases, right. However, they are very popular in the online space, like we have the RAC, DynamoDB, the Voldemort, the Redis. For example, in the online applications where you go for any online purchasing, when you push your products to the cart, and there they normally use the key value store databases, right. They are quite popular there because they are very fast and they are fast, efficient, and they are very good in partitioning, as I told you. So, then next came the columnar store. This columnar store databases started with Google Bigtable, and HBase as primarily copies the same format as the Bigtable. So, what this does is we have column store databases stores multiple rows, and each row has a unique key called the primary key or the row key, and each row key can consist of multiple column families. And the good thing here is each row can have different column families. They do not have to follow the same format. You can have one row can have 10 families and other row can have only one column family, right. They are completely independent. And column family themselves are the combination of columns where each column is stored as a value pair, right. And the advantage of this is it allows, along with your column key, you also have the row key. So, row level indexing is possible, which was not possible with the key value store, right. And some of the popular ones are the HBase, the Cassandra. Cassandra actually gives you another functionality on top of the other column families, which is the combining the unique key, combining columns. There is another level of extra key which you get in Cassandra for faster processing, right. Then you have Cumulo, and then you have Amazon SimpleDB and whole lot of databases available, right. And then came the document store. So, the good thing with document store is, of course, it can save data in any format. However, the data should be able to possible to store in terms of a document, and documents are primarily the JSON format documents. However, with I think MongoDB they store in bjson, which is binary JSON format of which is again a relative of the JSON scripts, right. So, and we have popular databases in the document store, which is the MongoDB, then the TerraStore, the Couchbase, and the CouchDB and stuff. So, the last one, and of course, one of the new ones in the category is the graph database. This is from the which comes from the graph theory, where all your data is stored in terms of vertices or nodes and edges, where each node can have its own property, and each nodes are connected to each other through these edges. So, the popular places where the graph databases are used in LinkedIn, where they store the professional connections, and your any social network, social media, and in your navigation system. So, they all use the graph databases. Yeah, the popular ones are Neo4j, then Infinite Graph, and many other, right. So, this is a kind of a very brief, keeping the time in mind, this is a very initial introduction to the NoSQL and the SQL databases. So, is there any questions you have? So, I hope you all have good understanding about the database, which what we are trying to do, we are trying to give you the overall picture of how machine learning and data come together. When you marry them together, what can be done, right. So, starting off with the data. So, let's come to the database application perspective, right. So, normally databases are divided into main categories, based on the response time and the workload, like how fast or how responsive you want your database to be, and how much of workload do you want them to handle, right? And so initially we have the real-time transactions. These are the operational databases where you're able to store data in real time, and they're primarily useful in the web and the IoT space. When you collect a lot of sensor data and the online activities from users, for these type of transactions, we use the operational databases, and also in the financial space as well. People use OLTP, right? And then comes somewhere in the middle is the real-time analytics. So where these databases are primarily meant for giving recommendations at a very quick time, right? Like when you go to Flipkart or Amazon, you do any shopping, you get the what you call collaborative filtering, which is the product recommendation based on what the past users have purchased. When you buy product A, then chances of buying the product B. So they are the real-time applications where you give faster recommendations, right? And then came the streaming analytics, where you process the data as and when the data arrives, right? So this is primarily used in the fraud prevention. When you want to immediately, like credit card transactions, where you want to immediately identify fraud and protect your customers. So and then came the slow side of the databases, which is called the operational database, analytical databases, or batch analytics, where you normally process data going back in history, where you collect large sets of data and probably do some predictive analytics, like formerly in the sometimes in the fraud detection, where you want to identify if any fraud has happened in the last 2 years or 5 years. So there are wide varieties of applications of databases, starting from OLTP to OLAP, which is the analytical platform, right? So on the OLTP side, you have the NoSQL databases like the Couchbase and Cassandra, and on the OLAP side, you have the Spark. So Spark, what is Spark? It is not a database, it is a processing engine, which works very closely with these NoSQL databases to provide real-time analytics. And this is something which I'll show you in the next slide. Yeah, a Spark is a unified engine which can connect anything and work on any kind of format, right? It can connect to databases, it can connect to Elasticsearch, Kafka, HDFS, Avro, Amazon S3, cloud computing, you name it. It connects, it can read data in any data format, either in text files or CSVs or Arrow or Avro or RPC protocols. So it will be, that's the whole advantage of Spark. It is extremely efficient in terms of running your machine learning algorithms, because it works primarily on the in-memory computing, as opposed to the MapReduce, a traditional MapReduce, which works on batch basis, right? And through computational graphs, we are able to achieve at least 10-20 times faster than the MapReduce, and more importantly, it improves usability. So as a user or as a data scientist, I can deploy my solutions faster, into the platform, because of the kind of API supports we get. Like we have Java support, Scala, and for R we have SparkR, and then we have PySpark for Python. So it has an extensive APIs that it can support, and which makes our deployment much easier. It also comes with an interactive shell, right? So and with the recent introduction to Spark 2.0, which is a big leap forward from the previous 1.x versions, it has a better structure streaming, which means our streaming analytics became much better. It has support to more competitive or advanced machine learning techniques, like what Nishant is going to talk about, the NLPs, the computer vision, the IoT space, and it has a great support from R. Yeah, you can write parallelized UDFs, and lot more things can be done, and of course it is much faster. So it's a framework for all your machine learning and all the processing, and with the advantage of connecting directly to all your NoSQL databases, or your RDBMS, or name like MySQL, or you have your Cassandra, or it makes it very popular in the cloud computing space as well for all our real-time applications. Yeah. So the best way to tell you about the Spark and the NoSQL is through an use case, right? So what happens when both of them can marry together? What things can be done? So for example, we have a use case of data integration, right? Now for example, assume you are one of the data engineers in LinkedIn, right? And you have a whole bunch of users and the user profiles. And if you want to add, for example, an user interest to your user profile, only for those, your high-end customers or the premium customers is what you say, right? So traditionally, what used to happen, normally we spend a couple of days in order to gather all the data from different databases, and run an overnight, ETL operations, then come the next day or after 2-3 days, and then push them all into the analytical database, and then you process your data, right? And then you generate insights and do whatever modification you want before you go to the customer. Well, today we don't have that much time and effort to waste. So with Spark and NoSQL, so what a LinkedIn engineer would do, he would, assuming your user profiles are stored in your NoSQL database, like Cassandra or a Couchbase, and then you have your user interest stored in HDFS, okay? And then you have, and then your transactions of all the customers stored in a data warehouse, right? You can use Spark to connect all three tables